In grade 7, you learned what a linear equation in one variable is. You also determined its solution set. For example, negative 3 times the quantity 8x plus 1 equals 7x plus 1 is a linear equation in one variable. So let's try to solve for x. So for the solution, so here we're going to multiply 8x plus 1 by negative 3. So we're going to apply distributive property here. So negative 3 times 8x is equal to negative 24x. And then negative 3 multiplied by 1 is negative 3. And this is equal to 7x plus 1. Now in solving for x, we need to group all terms with the variable x on the left side and the constant on the right side. So here we're going to transpose 7x to the left side and negative 3 to the right side. So here we will have negative 24x, and then 7x when transposed to the left becomes negative 7x, and this is equal to 1 plus negative 3 when transposed to the right becomes positive 3. So simplifying our equation further, so we can combine similar terms. So negative 24x minus 7x is negative 31x. And this is equal to 1 plus 3. That's equal to positive 4. And then to solve for x, we need to divide both sides by negative 31. So here, we will get x is equal to negative 4 over 31. And we call this value as the solution of the given linear equation in one variable. Okay, so here in this lesson, we will extend your existing knowledge to linear equations in two variables. What is a linear equation in two variables? A linear equation in two variables is an equation that can be written in the form ax plus by equals c. So we have this form of the equation. In this form, a, b, and c are real numbers, and a and b are not both 0. So meaning to say, the two cannot be 0 at the same time. But a can be equal to 0 provided that b is not, or b can also be equal to 0 but a is not. Okay? So based on this definition, let's try to determine whether the following equations are LETV or not. So let's start with number 1. X plus 3y is equal to 1. Okay? So based from our number 1 example, the equation x plus 3y is equal to 1 is already written in the form ax plus by is equal to c. So here a is equal to 1, b is equal to 3, and c is equal to 1. So all of which are real numbers. Okay, so we put a check mark here. So meaning to say this is a linear equation in two variables. How about number 2? 2x plus 1 is equal to 0. Okay, so sabi natin ang linear equation in two variables can be represented or can be written in the form ax plus by is equal to c. So if I'm going to do that, 2x plus 1 equals 0 can be transformed to 2x. So if I'm going to transpose 1 to the right side, I will have the equation 2x is equal to negative 1. Okay, so because I want to isolate the constant, okay? And I want to see the by term here, so I can also write it as 2x plus 0y is equal to negative 1. So since I was able to write it in this form, and a and b are not both equal to 0, then I can say that this one is also a linear equation in two variables. How about number 3? xy is equal to 3. Is there a way to write this form or this equation in the form ax plus by equals c? We cannot actually write it in the form ax plus by is equal to c. This should not be an LETV. So one condition for a linear equation is no variables may be multiplied together. There should be no product of variables. How about number 4? X squared is equal to y. Okay, so the equation x squared is equal to y is not an LETV because of the presence of the exponent 2. So one condition so that we can say that this one is a linear equation, two variables, is there should be no variables with exponents other than 1. Then last, number 5, 1 over x plus 2y is equal to 3. This one is not a linear equation in two variables. We cannot write it in the form ax plus by is equal to c because of the presence of the variable in the denominator. So one term has 1 over x, and then we can see that there's a denominator of x here. Okay, so if we're going to multiply both sides of the equation by x, we will have x plus 2xy equals 3x, where we can find a term with the product of x and y. So here, we should also note that there should be no variables appearing in a denominator. Now, a linear equation can be written in different forms, depending on what we know or what we want to know about the equation. The standard form and the general form are just two of these forms. The rule in writing a linear equation in its standard form varies from author to author. Many references say that a linear equation is in its standard form if it is in the form ax plus by equals c, where a, b, and c can be any real numbers. Some references, on the other hand, require that a, b, and c be integers and that a is positive. Some also require that a, b, and c should have no common factor other than 1. So for this math course, we will follow these requirements. So a linear equation is in standard form if it is written in the form ax plus by is equal to c, where a, b, and c are integers. What else? A is positive. And the greatest common factor of a, b, and c is equal to 1. Okay, so let's try to write some linear equations in two variables. So let's take a look at our first equation, 1/2 x plus 2/3 y is equal to 2. Of course, if we're going to look at this equation, you can say that this is a linear equation in two variables because 1/2, 2/3, and 2, which are the values of a, b, and c respectively, are all real numbers. But the question here is this equation written in standard form? Okay, so this is not yet in standard form. Bakit? Because if we're going to look at the coefficients of x and y, they are all fractions. Here, we mentioned that our line is in standard form if in the form ax plus by is equal to c, a, b, and c are integers. So since 1/2 is not an integer and also 2/3 is not an integer, so therefore we cannot say that this one is already written in the standard form. Since this is a linear equation to variables, then therefore it's possible that we can transform it to the standard form. So paano? Pwede natin gawin is to multiply the whole equation by the least common denominator of all the terms. Okay, so for example, looking at 1/2, 2/3, and 2, ano ba yung LCD nun? Ng mga terms na yon? The LCD is 6. So if we try to multiply this equation by 6, or both sides of the equation by 6, make sure that every term in the equation is multiplied by 6. So you have 1/2 x multiplied by 6 is 3x. And then 2/3 y multiplied by 6. So you have 6 divided by 3 is 2 times 2, 4 times y, plus 4y. And then 6 times 2, that's equal to 12. Okay? So we were able to write the standard form for that line. Okay? So here, satisfied na yung condition that a, b, and c are all integers. And then observe that a is positive. Positive 3 na yung value ng a. And looking at the values of a, b, and c, so for numbers 3, 4, and 12, the greatest common factor is equal to 1. So how about the equation negative 3x plus 4y is equal to 7. Is this equation already in standard form? Okay, so let's try to look at the values of a, b, and c. So a is negative 3, b is equal to 4, and c is equal to 7. So all of which are integers. So check tayo dito. Integers yung a, b, and c. On the second condition, a is positive. But here, the value of a is negative 3. So therefore, number 2 equation is not yet in standard form. Now, if we observe that the value of a or the coefficient of x is a negative value, then to make it positive, just simply multiply both sides of the equation by negative 1. So if we do that, the sign of every term is changed. So 3x yon. Then 4y becomes negative 4y. And then 7 becomes negative 7. This is now the standard form of the line. Another example. How about if we have the equation 4x minus 8y is equal to 16. Is this equation written in standard form? Okay, so let's try to check. A, B, and C, 4, negative 8, and 16 are all integers. Okay, so check tayo doon. And then looking at the value of A or the sign of A, so we have positive 4. So we have A is positive. Okay, so check na rin yun. But if we're going to check the GCF of A, B, and C, so ano ba yung GCF ng 4, negative 8, and then 16? As we observe, 4, 8, and 16 has other GCF other than 1. So if we're going to look at the values of A, B, and C, that is yung 4, negative 8, and 16, we observe that the GCF is 4. So meaning to say, we can still simplify this equation by dividing both sides of the equation by the GCF 4. So dividing both sides of the equation by 4, so that means we just have to divide every term by the GCF 4. What do we have? We have x minus 8 over 4y. So that's negative 2y is equal to 16 over 4. That's positive 4. So this is now the standard form of the line. Okay, so how about the general form of a line? The general form of a line is the equation ax plus by plus c equals 0, where a, b, and c are integers, a is positive, and the GCF of a, b, and c is equal to 1. So the conditions are the same as the conditions that we are looking from the standard form of a line. So the only difference from the general form of a line, in the standard form of a line, the x and y variables are found on the left side and the constant is found on the right side of the equation. But if we're going to write the equation in its general form, then we should just group all terms on one side of the equation, and then on the right side of the equation, we should find 0. Okay, so we have the equation ax plus by plus c is equal to 0. Okay, so here's a list of equations written in standard form and general form. Okay, so for example, yung 4x minus 8y equals negative 5, that's the standard form. And to write it in general form, we just have to transpose negative 5 to the left side. So you'll have 4x minus 8y plus 5 is equal to 0. Take note, in the general form, 0 is always found on the right side of the equation. But for the standard form, you can see the constant term on the right side of the equation. Okay. Another example, x plus y is equal to 1. That's the standard form. And then if we want to write it in general form, so we transpose 1 to the left side. So you have x plus y minus 1 equals 0. How about x equals negative 3? So sabi natin, if one variable is missing, it is still a linear equation in two variables. So for example, for x equals negative 3, this one is already written in standard form because the variable is found on the left side and then the constant is found on the right side. So here, the value of b is 0. So parang pwede natin siyang isulat na x plus 0y is equal to negative 3. But if one variable is missing, or let's say the value of b is equal to 0, then there's no need to write plus 0y in our equation. So for as long that the variable is isolated from the constant, then it is already written in standard form. Whereas for the general form, then we should group all terms on one side of the equation. So we have x plus 3 equals 0. So again, there's no need to write 0y in our equation. And then for the fourth equation, we have the equation y is equal to 8. That's already written in standard form. So here, the value of a is 0. So that means this is like the equation 0x plus y is equal to 8. There's no need to write 0x here. And for the general form, for y equals 8, we have y minus 8 is equal to 0. Now, let us try writing equations in standard and in general form. So for our first example, let's write 2 times the quantity x minus 3 equals 1 half y in standard form and general form. So for our solution, we copy 2 times the quantity x minus 3 equals 1 half y. And then on the left side of this equation, we can uh, multiply x minus 3 by 2. So using distributive property, we have 2 times the quantity x. So using the distributive property, we have 2 times x, that's 2x. Then 2 times negative 3 is negative 6. And this is equal to 1 half y. Now to get rid of fractions, we can multiply both sides of the equation by the LCD 2. So multiplying both sides by 2, we will have 2 times 2x is 4x. And then 2 times negative 6, that's negative 12, is equal to 2 times 1 half y is simply equal to y. And then on the standard form, remember that all the variables should be found on the left side of the equation. And then on the right side, we should see the constant term. So for this equation, we need to transpose y to the left side and then negative 12 to the right side. So it's the same as subtracting y from the two sides and then adding 12 to both sides. So what do we have? We have now 4x minus y is equal to 12. So this is now the standard form of the line. Okay, so this is now the standard form of the line. Now how about the general form? So for the general form, we just have to transpose 12 to the left side so that all terms are found on the left side. And then on the right side of the equation, we will see 0. So for that, for the equation 4x minus y equals 12, so we will just transpose 12 to the left side to have 4x minus y minus 12 equals 0. So this is now the general form of the line. Now let's have another example. So this time, we will write the standard form and general form for the equation x over 3 plus y over 4 equals 2x plus 1. So for our solution, what should be our first step? So again, writing first the given equation. So we have x over 3 plus y over 4 is equal to 2x plus 1. Now, I want to get rid of fractions first. So I can start by multiplying the equation by the LCD of all the terms. So here, we can see that the denominators are 3 and 4. So the LCD now is equal to 12. So I'm going to multiply this equation by the LCD 12. And so multiplying each term by 12, we have 12 times x over 3. That's equal to 4x. And then 12 times y. Then 12 times y over 4 is positive 3y. And then 12 times 2x is equal to 24x. And 12 times 1, that's positive 12. Okay? So here, we observe that all the coefficients are all integers. Now, let's try to group all variables together on one side or on the left side of the equation and leave the constant term on the right side. So for this one, we can transpose 24x to the left side. So we have 4x plus 3y negative 24x is equal to positive 12. And then we can combine similar terms like 4x and negative 24x. And then the result is negative 20x plus 3y equals 12. Now, the resulting equation, negative 20x plus 3y equals 12, is not yet the standard form because as we can see, the value of a is still a negative value. Okay? So it's a negative 20. So to make it positive, we just have to multiply the equation by negative 1. So multiplying both sides by negative 1, we will have 20x minus 3y is equal to negative 12. So this is now the standard form of the given equation. So we have the standard form. Okay. So again, for the general form, so let's just start with the standard form. 20x minus 3y equals negative 12. And then from this form, we just transpose negative 12 to the left side so that on the right side of the equation, we will see 0. So we have here 20x plus 3y plus 12 equals 0 as the general form. So this is the general form of the line. So now let's try to talk about the graph of a linear equation in two variables. The graph of a linear equation in two variables is a line consisting of the set of all points in the Cartesian plane whose coordinates xy make the equation true. Each of these points is referred to as a solution of the equation. Now, how will we know if a given point is part of a given equation's solution set? Let's have an example. Determine whether 0, 3 and 1, negative 4 are solutions of the equation 3x plus 4y is equal to 12. Okay, so for this problem, we have to determine whether the two given points are solutions of the equation 3x plus 4y is equal to 12. So for our solution, so let's determine first whether 0, 3 is a solution of the equation 3x plus 4y is equal to 12. Let's try to determine whether this one is a solution of 3x plus 4y is equal to 12. Remember that in the point 0, 3, that 0 is the x coordinate and 3 is the y coordinates. So meaning to say, in this point, the value of x is 0 and the value of y is equal to 3. So what are we going to do? So in the equation 3x plus 4y is equal to 12, we will replace x with the x coordinate 0 and y with the y coordinate 3 and see if the two values x equals 0 and y equals 3 satisfy the given equation. So substituting values, we have 3 times the quantity 0 plus 4 times the quantity 3 equals 12. So here, we're going to determine whether the two values satisfy the equation or not. So simplifying our equation, so we have 3 times 0, that's 0, plus 4 times 3 is 12. And is that equal to 12? So 0 plus 12 is 12. And that is equal to 12. So since the pair of values 0, 3 satisfy the equation, then we can say that 0, 3 is a solution. How about the second point? Let's have 1, negative 4. So again, to determine whether this point is a solution or not, then we just substitute the x and y coordinate of the given point in our equation. So we write 3 multiplied by the quantity 1 plus 4 times the quantity negative 4 equals 12. So simplifying the left side of the equation, we have 3 times 1 is 3 plus 4 times negative 4. So negative 16, is that equal to 12? So simplifying, 3 minus 16, that's equal to negative 13. And we see that this one is not equal to 12. So here, we have a contradiction or a false statement. So therefore, we can say that 1, negative 4 is not a solution. Okay, so we write 1, negative 4 is not a solution. Okay, so how about if we try to graph the equation 3x plus 4y is equal to 12? In the previous example, we found that 0, 3 is a solution of the equation. Thus, the graph of the equation contains this point. We need to find two more solutions of the equation to graph the line. To identify other solutions of the equation, we can select any value of x and use the equation to find the corresponding values of y. Remember, it is easier to solve for y if we isolate y first on one side of the equation. We have 3x plus 4y equals 12. So here I'm going to isolate y, or should I say I'm going to solve for y in this equation. So first, we transpose 3x to the right side. So we have 4y is equal to negative 3x plus 12. And then after that, since I want to isolate y, I will have to divide both sides of the equation by 4. So divide this term by 4, and then we also divide negative 3x by 4, and we also have 12 divided by 4. So what do we get here? So we have y is equal to negative 3/4 x plus 3. We just isolated y from the rest. Here, if we try to assign any value to x, we can easily determine the corresponding value for y because y is already isolated from the rest. So here we can just substitute the value of x or any value of x and then solve for the corresponding value for y. Okay, so let's try to graph this using table of values. So we're going to assign values for x and then we will solve for the corresponding value for y. So in our table, we can make use of a vertical table. So the vertical table looks like this. And the horizontal table will look like this. So here, to be able to graph, we just have to generate pair of values or solutions for the given equation. So since we already found out that 0, 3 is a solution, then the line will pass through 0, 3. Okay, so when graphing a line, sometimes it is easier to graph it if we try to find solutions with integer coordinates. So for example, x here is multiplied by negative 3/4. Okay, so if we wish to avoid fractions, then we can consider x values which are multiples of 4. So that, for example, if x is equal to 4 and then I multiply it by negative 3/4, then I will just have negative 3 added to 3. I'm going to choose values for x like negative 4, 0, and 4. So all of which are multiples of 4. So here we all know that y is equal to negative 3/4 x plus 3. So using the identified values of x, how are we going to solve for the corresponding value for y? We can write here when x is equal to negative 4, we have y is equal to negative 3/4 times negative 4 plus 3. And we have negative 3/4 times negative 4 is positive 3 plus 3. So what do we have? Y is equal to 6. So therefore, when x is 4, y is equal to 6. We perform the same with the other values of x. What if the value of x is 0? So of course, we already knew that the 0.03 is a solution to the given equation. So of course, if we try to replace x with 0, you have negative 3/4 multiplied by 0. That's 0 plus 3. So you will have 0, 3 here. Okay. And then last, when x is equal to 4, we have y is equal to negative 3/4 times 4 plus 3. Or that is negative 3 plus 3. So what do we have? Y is equal to 0. So when x is 4, we write y is equal to 0. These are the three generated points for the given line. So we were able to identify negative 4, 6 as one solution, 0, 3 as another one, and 4, 0 as another solution. So we have 3 points identified. It only takes 2 points to determine a line. But it would be good to plot a third point so we can be confident that our graph is accurate. So from the table, I'm going to plot now the pair of values that I got. Okay, so let's start with the first solution identified, negative 4, 6. This first pair of values represents the point negative 4, 6 on the Cartesian plane. So we just have to locate negative 4, 6. So where is that point? So from the point of origin, we count 4 units to the left and then 6 units up. So we locate this point here. Okay, so that is the point negative 4, 6. Now another point on the line is the point 0, 3. So where is that point? So 0 on the x and then 3 units up from the x-axis. So we have this point 0, 3. And then the third point is the point 4, 0. So since the y coordinate is 0, then that point should be located on the x-axis. So where is that point? This is the point with coordinates 4, 0. So after plotting all the 3 points, we now connect the points using a straight line. And remember to put arrowheads at both ends of the line. The 2 arrowheads mean that the line will continue indefinitely in both directions. After that, label your line. So here I'm going to label it as the line 3x plus 4y is equal to 12. Okay, so how about if there's a missing variable in the equation? For example, let's try to graph the equation y equals 4. The equation y equals 4 can be written in the form 0x plus y equals 4. Now for this equation, for any value of x chosen, y value will always be equal to 4. Thus, to graph this line, we can use any ordered pair with a y coordinate 4. So if we're going to make use of a table, for every value of x chosen, the corresponding value for y will always be equal to 4. So for example, if we choose negative 3 as the value for x, then the corresponding value for y is 4. Similarly, when x is 0, y is also equal to 4. And then when x is 3, y will still be equal to 4. This set of points is enough for us to graph the line y equals 4. Okay, so let's try to plot first the point negative 3, 4. So we locate negative 3, 4 on the Cartesian plane. So we have this point as the point negative 3, 4. Now another point from our table is the point 0, 4. And that should be located on the y-axis. So 0 on the x and then 4 on the y-axis. So we have this point. So this is the point 0, 4. And then last, the point 3, 4 is found on this part of the Cartesian plane. Now after plotting the 3 points, we now connect the 3 points with a straight line. And remember to always put arrowheads in your graph line. And then of course, we label it. So this is the line. Y is equal to 4. Now what do you observe with the equation's graph? Okay, so the graph is a horizontal line. Okay, so let's have our fourth and final example. Graph the equation 2x equals 7. So in this equation, this time, the y variable is missing and then we only have the x variable. Okay, so first, let's try to solve for x from our equation. So we write 2x equals 7. And then to solve for x, we divide both sides by 2. So we will have x equals 7 over 2 or 3.5. So for this one, we will leave it as a rational form. So we have x equals 7 halves. So in this equation, we will not be assigning values for x because in this equation, the x coordinate will always be equal to 7 over 2. We will just try to identify some points whose x coordinate is 7 over 2. So we can pair it with any value for y. So for our table, we have x equals 7 halves. Then we can pair it with another value for y. So let's say negative 2. Okay. So another pair can also be 7 halves paired with 0. And then another one, we can have the point 7 halves 4. After that, we plot the 3 points. So we locate this point. So this is the point 7 halves negative 2. Another point is 7 halves 0. So it's a point located on the x-axis. Next, our third point is 7 halves 4. And that point is found here. And then after plotting the 3 points, then we are now ready to connect these points with a straight line. And of course, do not forget to draw the arrowheads. Then after that, we label this as the equation 2x equals 7. Now, what do you observe with the equation's graph? Okay, so here we can observe that the graph of 2x equals 7 is a vertical line passing through x equals 7 over 2.